So for those of you who really like those factual comparisons of languages, this video is made just for you. It's high level, but I want to get into some of the really early similarities and differences between C++ and Java, so that way you have seen this knowledge somewhere and can start to catalog it in your brain when you start to go do your work. So let's start with basic data types. So of these basic data types, Java has them, C++ have them, and most of them are named the same thing. There's actually a little typo here because I think the slide automatically started to correct the PowerPoint automatically started to correct stuff. It's not capital B, it's lowercase b Boolean. So there you go. So it's Boolean and bool, and that one gets me frequently because I'm used to typing Boolean for Java, and you type the wrong thing for C, then oh yep, we take those extra characters out. Characters the same, floats the same, doubles the same, integers the same, short the same, long the same. Then the next one, it's not capital string, it's lowercase string for C++. But all the basic data types are there, and they're basically named the same thing. It's really important to understand, though, that text is quite different in C++. They both have strings. They both seem to have the ability to do strings. But in C++, strings they're frustratingly in between. So in Java, they're an object. In C++, they can behave as an array of characters, but they're still not an array of characters. There's some things you can do with strings that you can't do in Java that you can't do in C++, or they kind of you need to have an array of characters to do certain aspects in C++. We'll see that as we work on stuff. But just know, I habitually just say string, and I use that for text. In some cases, you should be dealing with pointers. Excuse me, pointers to character arrays instead of strings. All right, I've been doing a few of these. I think my voice just needed to be cleared out. Okay, so Java, as we noted in another video, automatically includes strings as part of the java.lang automatic imports. In C, you have to tell in each file you're going to use a string, you have to include the file and then use the namespace as well if you want to use it just the word string. So there's also a little subtle difference inside of there. In Java, we also have that implicit toString behavior that will automatically take an object and turn it into a string. C++ does not have that built into the hierarchy by default. A class does not automatically have that. You can actually create something that looks like it. We'll see an example of that using the operators, the same operators you'll see working with cout and such. Note there is something called to_string. That is for taking a number, an integer, a floating point or whatever, and then converting it into a string character at that point. So it does not implicitly concatenate the same way that Java does as well. I have to convert those things explicitly in C++. So some of these things that if you just are really fluid in Java and you just kind of write, they'll kind of catch you up on some of the tech stuff. I've adapted fairly quickly on that each time I've returned to C++. Um, oh yeah, I guess I did talk about this a little bit more here. If I want to take an object in C++ and convert it to a string, I have to use this big fancy operator. So the standard object string, there's actually a pointer right there, that's what gets returned right here. So this is the return value. Then I have an operator right here. This is how C++ allows us to change the behaviors of operators. Kind of a cool feature. I missed that in Java, but I've seen Ada and other languages that use the same feature. It's quite fun for syntax, where it takes in a string and it will write out a stream, excuse me, and then write out this value. Is what the operator does. So basically, it's for the stream on the left hand side of the operator, write the value on the right hand side of the operator. So by overwriting this method, it allows us to be able to print something out. So as an instance here, I can have the toString equivalent. This is the explanation of it, where I take a string stream, which is another built-in class, and I can take that object and I can write it to a string stream, and then you know return that as a string, for instance. So this is a way of being able to wrap around a toString like Java method. It's not built in. This is not a C++ thing. This is a Java conversion thing. But just to have that in your mind of how that happens. All right. So the good news of moving to C++ is there is a ton of this that is really functionally the same. Your basic decisions, loops, and calls to subprograms are basically all the same. The syntax is the same. The dot operators work in most cases. Parameter passing is quite different. So it's something that we really want to be aware of. That the parameter passing. When we get into pointers, a little bit different. Java is always passed by value for primitives and passed by reference for all objects. In C++, it'll actually copy a whole object inside of there if you're not careful. So you have to be be careful and aware of how you pass things along, depending on how your data types are structured. As far as basic input output goes, Java has your system.println and your scanner buffer, whatever, to get stuff in. C has the cout or the cin. There's actually a print statement in C as well, the print to standard output. So there's printf is the most useful of that. So it is similar, but you'll often see cout and cin. If you see print, you'll guess what it is. So for instance, if I have system.println, I can go through and concatenate all sorts of data structures together. The plus operator is overloaded like crazy in Java. That'll take strings, add them to numbers, add them to booleans, add them to objects using the toString. The equivalent in C is your cout, where the operator, the arrow, the let's see, what's that? Greater than. So this operator here concatenates all the pieces instead of the plus operator. So basically, this just keeps tacking everything into cout. And then I can add in different values along the way as well that are strings. But if I need to put in numbers, I have to use that toString that we saw before. Another interesting aspect here is the way I structure the code. So in Java, everything gets put into one file where the name of the file has to match the name of the class. C++ by default splits everything into two files for the most part. You don't have to have two files, but there's a header, which is what other people can see of your class, and that's the interface of your class. Your header, as we'll see in a bit, can have a public and a private section as well, but your implementation tends to be in a different file, the .cpp, C++ file. That's your implementation that holds most of your code. If you have something that's in your .cpp that's not in your header, nobody else can see that as part, because it's not in your interface. But if you have something in your header, it can be used, it can be accessible as part of your interface, but there's kind of some interesting, strange rules around that. There's no strict naming conventions. You actually have to explicitly tie implementations from your from your CPP class to your header class. And then the biggest thing that trips me up occasionally is Java allows you to code anywhere in the class, and you can see it everywhere in the class. C++ can only have visibility, can only see things that happen higher than it in the class. So think of it this way. For the first chapter of a book to be aware of what happens of the last chapter of the book is possible in Java, but in C, the first page of the book has no idea what comes after that. If you can't reference things that are about to come in the future, essentially. If you want to do that, you have to put up in the header first. So that's kind of an old school coding thing. I mean, honestly, I'd forgotten about it until I came back to C++ several years ago, because I learned C 25 years ago, but that's not the way most languages do it. It's kind of a holdback right there. One of the big things I had talked about before is the idea of data management life cycles. And so variables are quite different in C++. In Java, it handles the variable lifecycle for you. You create variables anytime you want to, and the garbage collector will clean them up after you. So really the differences between pointers and values are there's not much ado about them. In C, you have to be highly aware of how you declare variables, when you declare variables. You have to identify how you're going to pass them. You have to identify the syntax that you're going to use to talk about what way you're going to pass them. So it's not important for now, but just know this might come up occasionally as you try and do something you're used to doing in Java. You might not be able to do that without engaging the difference between a variable and a pointer to a variable very explicitly. And we'll cover that more as we go. All right, so there is a quick introduction to a lot of the differences between um, Java and C. And most importantly, what's a lot of what's the same between the two of them. So keep diving in. Watch some of the videos about how to do some stuff because that'll pick up more information. But then there'll also be a few things like this. Load your system 2 up with some facts to help guide your system 1 when it's not sure what to do.